Dear student, I am Mohammad Qasim Khan from Department of Computer Science. Today we will study unit number 3 of our course Information Security. In this unit we will study ISO model, network security and protocol. In first part of this course, this unit, we will study the ISO model, which is called the reference model or 7-layer model. ISO model. ISO stand for International Organization for Standardization. The ISO model reference model, commonly called the Open System Interconnection model, is conceptual framework that standardize how computers communicate with each other over a network. It was developed by International Organization for Standardization in 1984 to ensure that devices and softwares from different manufacturers can communicate effectively. The ISO reference model divided the communication process into 7 distinct layers, which each layer performs specific function and interact only with the layer immediately above and below of it. Communication between computers over network is made possible using protocols. A protocol is a set of rules, regulation, or instructions that defines how data is transmitted over a network medium like twisted pair cables, wireless medium, etc. Protocol make computer to computer communication possible. In early days of computer networking, many companies had their own proprietary protocols, which meant interaction between computers of different vendors was often difficult, if not possible. An effort to eliminate this problem, the International Organization for Standardization developed the ISO reference model for protocols. ISO standard 7498 defined the ISO reference model, which is called OSI reference model. History of OSI model. OSI model was not the first or only momentum. History of OSI model. OSI model was not the first or only moment to streamline networking protocol or establish a common communication standard. Most widely used protocol today, the TCP/IP protocol, which was based upon the Defense Advanced Research Project Agency DARPA model, also known now as TCP/IP model, was developed in early 1970s. The Open System Interconnection Protocol was developed to establish a common communication structure or standard for all computer systems. OSI reference was never widely adopted, but the theory behind the OSI protocol, the OSI model, was readily accepted. The OSI model serves as the abstract framework or theoretical model for how protocol should function in a ideal world on ideal hardwares. OSI model has become a common reference point against which all protocol can be compared. The functionality of OSI model is networking tasks divided into 7 distinct layers. Each layer is responsible for performing specific tasks or operation toward the ultimate goal of supporting data exchange, network communication between two computers or two devices. Always numbered from bottom to top. They are referred to by either their name or their layer number. For example, layer 3 is also known as network layer. ordered specifically to indicate how information flows through the various levels of communication task. Layers are said to communicate with three layers other than that. Each layer communicate directly with the layer above it as well as the layer below it, plus the peer layer on the communication partner system on the other side. This standard or guide provides a common foundation for the development of new protocol networking services and even hardware devices. By working from the OSI model, vendors are able to ensure that their product will integrate with product from other companies and be supported by a wide range of operating systems. If vendors develop their own networking framework, interoperability between products from different vendors would be next to impossible. The real benefit of OSI model is found in its expression of how networking function. Network communication occur over the physical connection. This is true even if wireless networking devices are employed. Physical devices establish channel through which electronic signal can pass from one computer to another and communication channel. Physical device channel are only one type of the seven layer logical channel type defined by the OSI model. Each layer of the OSI model communicate via a logical channel with its peer layer on other computer. This enable protocol based on the OSI model to support a type of authentication by being able to identify the remote communication entity as well as authenticate the source of the received data. There is two type of communication task performed by the layer: encapsulation and de-encapsulation. OSI layer add a head and tail to encapsulate the message. Encapsulation occur as the data moves down through the OSI model layer from application to physical layer. The inverse action occurring as data moves up through the OSI layers from the physical to application is known as de-encapsulation. The task performed during encapsulation and de-encapsulation is: first, the application layer create a message. We called it protocol data unit. The application layer passes the message to the next layer called presentation layer. The presentation layer encapsulates the message by adding information to it. Information is added at the beginning of the message called header, as we discussed, and at the end of the message called the footer or tail. The process of passing the message down and adding layer specific information continues until the message reaches the physical layer. At the physical layer, the message is converted into electronic or electrical pulses called current that represent bits and as transmitted over the physical connection. The receiving computer captures the bits from the physical connection and recreate the message into physical layer. The physical layer strips off its information and sends the message up to the data link layers. The data link layer strips its information off and sends the message up to the network layer. This process of de-encapsulation is performed until the message reaches the application layer. When the message reaches the application layer, the data and message is sent to the intended software recipient. The information removed by each layer contains instruction, checksums, and so on that can only be understood by the peer layer that originally added or created the information. The transmission of the data are labeled with the different names. The message sent to the protocol stack at the application layer, layer number 7, is called the data or protocol data units. Once it is encapsulated by presentation layer, layer 6, it is called a PDU, protocol data unit. It remains the label of PDU until it reaches the transport layer, layer number 4, where it is called the segment, where the whole message is divided into different chunks of data called segments. And the network layer, layer number 3, it is called packet or datagram. And the data link layer, layer number 2, it is called a frame, where the IP addresses are added. And the physical layer, layer number 1, the data become converted into bits of information for transmission over the physical connection medium. Now we will discuss the layers in little more detail. Physical layer accept the frame from data link layer and convert frame into bits for transmission over the physical connection medium and 10 format. Responsible for receiving bits from the physical connection medium and converting them back into frame to be used by the data link layer. And telecommunication industry standards and high speed serial interface, synchronous optical network SONET, and various standards are employed. Physical layers through the device driver and these standards. Physical layer control throughput, the rate of data transmission, synchronization, line noise, medium access, digital or analog signals, light pulses or transmitted received data over the physical hardware interface. Network hardware devices that function at physical layer or layer 1 or network interface card, hubs, repeaters, concentrator, and amplifiers. These devices perform hardware-based signal operation, such as sending a signal from one port out on all ports or hubs, or amplifying the signal to support greater transmission distances or repeater. Next is data link layer, responsible for formatting the packet from the network layer and to the proper format for transmissions. The proper format is determined by hardware and the technology of the network. There are numerous possibilities such as Ethernet, token ring, asynchronous transfer mode (ATM), fiber distributed data interface (FDDI), copper data interface. Resides the technology specific protocol that convert the packet into a properly formatted frame. Once the frame is formatted, it is sent to the physical layer for transmission. Data link layers have some protocols which are working under this layer. Serial line protocol is called SLIP, point to point protocol, address resolution protocol ARP, reverse address resolution protocol, line to forwarding protocol, and layer 2 tunneling protocol, point to point tunneling protocol, integrated service digital network ISDN. These protocols are working under the data link layer. Network layer responsible for adding source and addressing information to the data, and also the routing of data transmission over the network. The network layer accepts the signal or segment from the transport layer and add information to it to create packet. The packet include source and destination IP addresses. Protocol working on this layer: Internet Control Management Protocol, Routing Information Protocol, Open Shortest Path First Protocol, Border Gateway Protocol, Internet Group Management Protocol, Internet Protocol, Internet Protocol Security, Inter Network Packet Exchange Protocol, Network Address Translation Protocol, and Simple Key Management for Internet Protocol. Now, transport layer is responsible for managing the integrity of a connection and controlling the session. Accept protocol data unit from the session layer and convert it into different chunks of data called segments. Controls how devices on the network are addressed or referenced. Establish communication connection between nodes. Define the rules of session. Session rules specify how much data each segment can transmit. How to verify the integrity of the data transmitted. How to determine if data has been lost during the communication or during transmission. Session rules are established through a handshaking process. Transport layer establish a logical connection between two devices and provide end-to-end transport services to ensure data delivery. Mechanism for transmission is segmentation, sequencing, packets, error checking and packets, controlling the flow of packets, error correction during transmission and any packet, multiplexing, and network service optimization. Protocol operating under the transport layer or Transmission Control Protocol (TCP), User Datagram Protocol (UDP), Sequenced Packet Exchange (SPX). Thank you for your attention. This concludes our first part or lecture 3, unit 3. Please review today's topic and prepare for the next part of this unit. Thank you. Allah Hafiz.